everyone, my name is Sarah, and today we are going to talk about how vaccines are made on a large scale. So we're in the middle of this pandemic, right? And probably the word that you hear the most these days is vaccine, vaccine, vaccine. Everyone is wondering when we're going to have a vaccine. Russia has already released what they say is a vaccine, but no one's really sure. Everybody is talking about vaccines. So we were curious, what exactly goes into developing a vaccine and then giving it to people on a very large scale? So I actually wrote this article about it, so I hope you like it. But yeah, because the text is a little bit small, we're going to go through it one sentence at a time. So, and there's some difficult stuff in here, so if there's something that you don't understand, it's okay. I'm going to explain everything, and you can always pause the video or go back if you need to hear something again. All right, should we get started? Okay. Since the declaration of the COVID-19 pandemic, vaccine development has become the buzzword of the current era. Despite promising candidates from Russia and Britain, experts surmise that a vaccine will only be available to the public by mid-2021. I know, it seems like 2020 is just going on forever. I also kind of wish it would just end, but I mean, there's a bright side. At least by 2021 or 2022, we should be at the end of this, hopefully. So, okay, let's break this sentence down. Since the declaration of the COVID-19 pandemic. So declaration here, it means when the pandemic was officially started, or when the WHO or certain countries officially made a statement or an announcement or a speech that said, okay, it's a pandemic and we need to get prepared. So you'll see this used a lot. You can declare war, you can declare bankruptcy, you can declare independence even. We have the Declaration of Independence in the United States. So yeah, basically it's just a fancy word for stating something, saying like, this is how it is. So ever since the COVID-19 pandemic has officially started, vaccine development has become the buzzword of the current era. So a buzzword, it's kind of like a hot topic, something that you hear about all the time, almost like everyone's talking about it so much, it's almost like buzzing in your ears. So that's what we call it, a buzzword. And this is a pretty commonly used word in spoken and written English, so definitely applicable to the current situation. So despite promising candidates, experts surmise that a vaccine will only be available in 2021. So promising, that's a good thing. Basically, it means that the vaccine candidates have potential. People think, okay, this might work, but we're not actually 100% sure yet. So for instance, students can be promising, or someone who just started working at a company, they can be promising. That means that the people who are above them, they think, oh, this person is going to succeed if they work hard and use the right resources. So we have promising candidates, vaccines that we think might work from Russia and Britain. But despite that, experts still surmise or predict that the vaccine will only be available in 2021. So, a little sad. Zoom-fatigued netizens, exasperated with the economic, psychological, and death toll of the pandemic, may think that 8 to 12 more months is too long to wait. However, vaccine development is a complex and delicate process. So, how many of you are taking classes on Zoom? How many of you like taking classes on Zoom? Yeah, I don't really like taking online classes either because just looking at the screen all day, it makes me really tired. It makes me feel really fatigued or like 피로. So I'm just so sick of looking at Zoom on my screen all day. I'm feeling exasperated. I'm feeling frustrated. I'm feeling impatient because the economic, psychological, and death toll, the cost of this pandemic, it's just so great because the economy is losing a lot of money. There's a lot of psychological stress. People are very anxious. We don't know what's going to happen tomorrow. And then, of course, I mean, millions of people have gotten sick, and a lot of them, unfortunately, have died. So it's a very stressful and difficult situation that we're all in. I'm sure that you've all heard this already from your own friends and family, but I just want to emphasize I am in the same boat. I feel the same as you as well. So we're tired of looking at the screen. We're exasperated with the costs, both economic and psychological, of this pandemic. So we think, 8 to 12 more months of this, I don't know if I can do it. But the thing is, we have to be patient because vaccine development is a very complex or complicated and delicate process. So it's very difficult, and if you make one little mistake, it can go really badly for a lot of people. So we gotta be careful. So what is a vaccine exactly? Well, vaccines are a weakened form of an illness that train the body's immune system to produce antibodies to fight off diseases. Developing vaccines that are safe and effective requires vast amounts of money and time. So when someone gives you a vaccine, basically it's preparing your immune system, the thing that keeps you from getting sick and dying inside of your body. It's telling it in advance what the disease is and exactly how to fight it off or just prevent it from making you ill. So because the vaccine, it's just like a weaker version of the actual virus or infection. So once your body learns how to fight it off one time, it remembers forever. So if you get a COVID vaccine, for instance, it's a weakened form of the virus. It's injected into your body. Your body will learn how to fight it off, and then you don't have to worry about getting sick or dying from COVID because your body already knows how to protect you. So it's a pretty complicated process, and developing vaccines that are both safe and effective, that do what they're supposed to do, requires vast or huge amounts of money and time. So how does it exactly work? First, scientists must decode the genetic sequence of the disease. Then, they must choose and implement a strategy of either inactivating, weakening, or genetically editing the virus. After a potential candidate is developed, it must be tested to ensure that it is safe for widespread use. So, first of all, in order to make a vaccine that is similar enough to the actual disease to be able to train your body to fight off the disease, they have to decode the genetic sequence. So they have to find this virus or this illness and find out exactly how it's made. What is it made out of? Is it DNA? Is it RNA? Is it something else? And then what exactly about it is it that makes people sick? So after they do this, they have to choose and implement a strategy. So they choose and then put to use, or like 활용하다, a strategy. And they have three choices. One is inactivating the virus and injecting that into the human, weakening the virus, or genetically editing the virus. So we just said that they have to decode the genetic sequence, right? So if they just put the regular virus into your body, well, that's actually not going to protect you. It'll actually make you sick. So by genetically editing, just snipping some stuff off, putting some new stuff on, they can introduce your body to the virus, but make sure that the virus is not strong enough to actually make you sick. So this is really, really cool stuff. I am not a scientist, so I definitely cannot do something like this, but it's really exciting that we have this kind of technology. Okay, so first, they have to decode the genetic sequence, and then they have to pick a strategy and use it. And then after a potential candidate is developed, it must be tested to ensure that it is safe for widespread use. So if you're using these diseases to make a vaccine, you can't just, okay, I made the vaccine, now you buy it and just put it in your body. That's not good, because we need to at first do some experiments and make sure that the vaccine is actually safe. Because, for instance, what if we make the vaccine too strong and it makes people sick? Or what if we make the vaccine too weak and it doesn't actually protect people from getting the real disease? So, and there also might be some side effects that might be hurtful or even deadly for some people. So we have to make sure that it's actually safe and effective. So before we give it to a whole bunch of people and just for widespread use. So for use by lots of people in lots of places. Okay, so there are 3 phases. During phase 1, small groups of people receive the trial vaccine. Okay? In phase 2, the clinical study is expanded. In phase 3, the vaccine is given to thousands of people and tested for efficacy and safety. So when we're making a vaccine like this, you have to start small, because lots of people are developing hundreds, maybe even thousands of different vaccines for the same illness. But it's really hard to conduct experiments with thousands of people from the very beginning, especially if you don't know if it's actually going to work. So first you start with a small group, and then in phase 2, you expand the group, you make it bigger. And then in phase 3, you give it to a lot of people, like thousands of people. And the reason that we do this is because the more people that we have, the more data we can input into the research. So we know by looking at these thousands and thousands of people who got the trial vaccine, the phase 3 trial vaccine, and then we can see if it has efficacy, does it work, and is it also safe? Does it hurt people or not? Vaccine trials are a rigorous and time-consuming process, and volunteers must be carefully vetted and monitored for months. Only after the vaccine is declared safe can it be approved for mass production and use, which itself takes time, depending on the availability of facilities, supplies, and transportation infrastructure. So lots of kind of tricky words in here. Sorry, it's my fault. But yeah, so vaccine trials are a rigorous and time-consuming process. So we just saw right here, it's got 3 phases, and each of them takes a lot of time, it takes lots of people, it takes lots of money. So it's a very rigorous, very demanding, very difficult process. And it takes a lot of time. And not only that, you can't just spend the time and the money. You also have to make sure that you carefully vet or choose or select, and then also monitor the volunteers who receive the trial vaccine for months. So if I give someone the vaccine and then I only wait 1 week and they're fine, and then I say, okay, the vaccine is safe, and then 1 week later they get really ill, that's not such a good thing, is it? So we have to wait for quite a few months before we know for certain that the vaccine is actually safe. And so only after the vaccine is declared safe, after all of these steps, can it be approved for mass production, so, or production for lots of people in lots of places. However, even if we have a vaccine, if the vaccine has some kind of chemical that's really rare, or it requires some kind of special factory that is not available in every country, it's going to take time to get all of the resources to the places where they need to go, make the product, and then get it to the people that need it. So now you see why it takes so long. So yeah, because not every country has the special scientific facilities or the manufacturing facilities to make these kind of vaccines. And a lot of times those countries also don't have the money to buy the vaccines from other countries. So it can be quite a problem. And then also transportation infrastructure is a huge issue. For instance, there are countries where not every country in the world is like Korea, where it's super easy to get from one end of the country to the other. There are countries where some of the roads are still made out of dirt and not everybody has a car. So maybe they have the vaccine in that country, but if the doctors can't get to the people or the people can't get to the doctors, then they can't get the vaccine. So it's a very complicated process. So until that day comes, hand washing, masks, and social distancing are our best defense against COVID-19. So I know all of you must be feeling so impatient. You want to go back to school, you want to go back to work, you just want to go back to normal life. And I know, and I completely understand that. I feel exactly the same way. But I mean, the reality is, if we want a vaccine, we're going to have to wait for it, unfortunately. And even if we are able to get the vaccine within the next 8 months to a year, that will be the fastest that any vaccine has ever been developed on this kind of scale before. So what we're asking the scientists to do, it's a lot. And they're doing their best, and we can only hope that things will get better. But at least for now, we just gotta do our part, wash our hands, wear a mask, and social distance if it is at all possible. This is our best defense or protection against COVID-19. All right, well, that is our article for today. I hope that some of you learned something new, whether it be English or something about vaccine production or how exactly they're made. This was an interesting article to write, especially since, like I said, everybody's talking about vaccine all the time. So yeah, I hope that you enjoyed watching this video as much as I enjoyed making it, and I hope that all of you have a wonderful and safe and healthy day. All right, see you guys next time. Bye.